Imagine looking into the darkness of space and discovering a world with no star to call home, a giant planet wandering alone through the galaxy. Now, imagine learning that this mysterious planet is moving through our cosmic neighborhood. Astronomers have discovered rogue planets before, but every new discovery raises a chilling question. Where did these worlds come from, and where are they going? A rogue planet is a planet that does not orbit a star. Instead, it travels freely through space, separated from the planetary system where it may have been born. Some may have been violently ejected from young solar systems after gravitational encounters with larger planets. Others may have formed in isolation, more like stars, collapsing from clouds of gas and dust without ever becoming part of a normal planetary system. The idea of a giant world racing through interstellar space sounds terrifying. But space is enormous, almost unimaginably enormous. Even when astronomers describe an object as approaching our region of the galaxy, that does not automatically mean it is heading toward Earth. Still, the discovery is fascinating because rogue planets can reveal something extraordinary about how planetary systems evolve. Our own solar system may appear stable today, but billions of years ago, its planets were engaged in a chaotic gravitational dance. Worlds could have shifted their orbits, collided, or even been thrown into deep space. A massive, rogue planet passing through another stellar neighborhood could influence objects through gravity. Comets might be disturbed. Small, icy bodies could be redirected. Distant planetary systems could experience subtle gravitational changes long before anyone noticed the cause. But there is an important distinction between scientific possibility and immediate danger. A planet can be moving toward the general neighborhood of our solar system without being on a collision course with Earth. Astronomers carefully calculate trajectories. The discovery of rogue planets. Scientists have discovered giant planets that travel through space without orbiting a star, making them mysterious, wandering worlds. The discovery of rogue planets has opened one of the most fascinating chapters in modern astronomy. Unlike Earth, Jupiter, or Saturn, which orbit the Sun, rogue planets travel through space without being gravitationally bound to a star. These mysterious worlds can move silently through the darkness of the galaxy, receiving little or no light from a nearby sun. Because they do not shine brightly, detecting them is extremely difficult, and scientists often have to rely on indirect evidence to find them. A rogue planet can be enormous, potentially several times more massive than Earth, or even comparable to the giant planets in our solar system. Imagine a world larger than Jupiter drifting alone between stars. It would be a completely different kind of planetary environment, surrounded by darkness and extreme cold at its surface. Yet deep inside, it could still contain tremendous amounts of heat left over from its formation. Scientists can sometimes identify these wandering worlds through a phenomenon called gravitational microlensing. When a rogue planet passes in front of a distant star from our perspective, its gravity bends the star's light and briefly makes the star appear brighter. This tiny change can reveal the presence of a planet that would otherwise remain invisible. The existence of these worlds also challenges our understanding of planetary systems. They may have been born around stars and later thrown away by powerful gravitational encounters. Their journeys show that planetary systems can be far more chaotic than they appear today, and the galaxy may contain billions of these lonely travelers moving silently through space. How rogue planets are created. These planets may have been violently ejected from their original solar systems through powerful gravitational interactions, or they may ha. One of the biggest mysteries surrounding rogue planets is how they become travelers without a star. Scientists believe that many of these worlds may have originally formed inside planetary systems, just as Earth and the other planets formed around the Sun. In the early stages of a young solar system, however, planets can experience powerful gravitational interactions. Giant planets compete for stable orbits, and their enormous gravitational forces can dramatically change the paths of smaller worlds. Imagine a young planetary system filled with several massive planets, moving through a crowded region of space. A close gravitational encounter between two giant planets could give one of them an enormous change in velocity. That gravitational slingshot could send another planet outward, beyond the system's outer boundary. If the planet gains enough speed, it may escape the gravity of its parent star completely. From that moment onward, it becomes a rogue planet. There is also another possibility. Some rogue planets may form independently from clouds of gas and dust, without ever becoming part of a traditional star system. In that case, they would be more like planetary mass objects created directly in the interstellar environment. Either way, the result is extraordinary, a planet without a permanent star. For the planet itself, being ejected would transform its environment. Without a nearby sun, its surface could become unimaginably cold. Any atmosphere might freeze or collapse, while oceans on the surface could eventually turn into thick layers of ice. Yet beneath that frozen exterior, internal heat could potentially remain for a very long time. These lonely worlds demonstrate that planetary systems are not always peaceful or permanent. Gravity can create planets, reshape their paths, and even send them into the darkness between the stars. The most frightening part of discovering a giant rogue planet is the possibility that it could be moving through our cosmic neighborhood. But there is an important difference between a planet traveling toward our region of space and a planet actually being on a collision course with Earth. The distances between objects in the galaxy are so enormous that even a planet moving in our general direction could still remain millions or billions of kilometers away. Astronomers can calculate an object's path by measuring its position, velocity, distance, and gravitational interactions. With repeated observations, scientists can determine whether a rogue planet is approaching the solar system, passing nearby, or simply traveling through another part of the galaxy. These calculations are extremely important because appearances can be misleading. An object that seems to be racing toward us may actually be following a trajectory that takes it nowhere near Earth. The Sun also provides enormous gravitational protection for the architecture of our planetary system. Earth is deeply embedded within the Sun's gravitational field, and a distant rogue planet would need to pass exceptionally close before producing significant changes to Earth's orbit. Even then, its effect would depend on its mass and exact trajectory. That does not mean such an encounter would be completely harmless. A sufficiently massive planet passing through the outer solar system could disturb distant comets, asteroids, and icy objects. Some could have their orbits changed, potentially sending them toward the inner solar system. But there is no reason to assume that every newly discovered rogue planet represents an immediate threat. The real story is much more fascinating. Scientists are learning to track invisible worlds traveling through the darkness, turning mysterious movements in space into measurable cosmic journeys. A sufficiently massive planet passing close to our solar system could disturb comets, asteroids, and planetary orbits. However, space is enormous, and a distant rogue planet would have little effect on Earth that a truly massive rogue planet passing relatively close to the solar system could create dramatic gravitational effects. But the outcome would depend almost entirely on its mass, speed, distance, and trajectory. Space is incredibly vast, so even an enormous planet could pass through the broader neighborhood without causing any noticeable change on Earth. However, if such a world came close enough, its gravity could begin disturbing objects at the outer edges of our planetary system. The first signs might appear among distant comets and icy bodies. These objects are loosely bound to the Sun and can have extremely long, unstable orbits. A passing rogue planet could alter their trajectories, sending some farther into interstellar space while pushing others toward the inner solar system. Over very long periods, this could increase the number of comets entering the region around the Sun. The planets themselves would be much harder to disturb. Earth, Venus, Mars, and the other major planets are strongly controlled by the Sun's gravity. A rogue planet would need an extraordinarily close encounter to produce a significant change in their orbits. If it were massive enough and passed through the right location. However, even small gravitational changes could accumulate over time. The most dramatic possibility would be a direct encounter with one of the planets or a close passage through the inner solar system. Such an event would be extraordinarily unlikely, but the physics would be spectacular. Orbits could shift, moons could be disturbed, and smaller bodies could be thrown into entirely new paths. Yet these scenarios remain possibilities, not predictions. The important lesson is that gravity connects everything in space, even an invisible world wandering between stars. Why this discovery matters. Rogue planets provide scientists with clues about the violent and unpredictable history of planetary formation. They remind us that the galaxy is filled with mysterious worlds moving through the darkness beyond what we can see. Rogue planets may be among the most valuable discoveries for understanding how planetary systems are born, evolve, and sometimes fall apart. For a long time, scientists mainly studied planets that orbit stars because those worlds are easier to detect and observe. But wandering planets reveal another side of planetary evolution. A world does not necessarily remain where it was born. Every rogue planet could carry evidence of a dramatic history. Perhaps it was once part of a young planetary system where several giant worlds competed for stable orbits. A gravitational encounter may have thrown it away, transforming a planet with a parent star into a lonely traveler. If scientists can determine how common these objects are, they could gain important clues about how frequently planetary systems experience violent gravitational events. These worlds also challenge the idea that planets must depend entirely on sunlight. A rogue planet would receive almost no energy from a nearby star, yet could still contain internal heat generated during its formation and from radioactive elements deep inside. In some cases, scientists have even considered whether underground environments beneath thick layers of ice could remain warm enough to support unusual chemistry. Perhaps the most important discovery is simply that our galaxy may contain enormous numbers of planets that remain hidden in the darkness. The stars we see represent only a fraction of the objects moving through the Milky Way. A giant rogue planet racing through space therefore represents more than a mysterious cosmic threat. It is a reminder that the universe is dynamic and unpredictable. These wandering worlds can help scientists reconstruct the violent history of P.